how comfortable are you working with variables? What do you think?
Yes.
What's a variable?
X.
That is one variable. What is a variable? It's a replacement for a number, and usually it's a letter. Exponents and powers. Raising things to a power. 3 squared, what's that? What's the power in 3 squared? 2. What's the base? 3. Yeah, you got it now. Order of operations, what's that word you have to remember? PEMDAS. P-E-M-D-A-S, yeah. A problem-solving model, problem-solving plan using models. This is where, remember, this essentially is that word problem plan. You really need to look that up. That's important. You definitely will have word problems on the test. Remember what I said about expressing your answers properly? You need to be able to express it properly and explain what you're doing. So definitely that's a huge one to review. Tables and graphs, statistics. Do you remember when we looked at statistics? You had to read a table, maybe plot the points. Kind of, maybe sort of. Yeah, like well, this was before scatter plots. This was just like understanding what a table of data is, and most of you knew that already. And then an introduction to function. What is a function? If you had to define a function, what is it? About the real number line briefly. Okay. What are real numbers? I'll start. Any number what? Yeah, any number on the real number line is a real number. So if the number has a home on the real number line, it's a real number. Do you have to know exactly where the number is? No. So for example, square root of 2. Do you know exactly where the square root of 2 is? No, it's an irrational number. You don't know exactly where it is, but it's between 1 and 2 somewhere, right? Do you know where it is? Nope. But is it on the line? Yep, so it's a real number. Can you add and subtract? What do you think? You pretty good with that? What about multiplication? Nah. Distributing, is that kind of important? And division. Have you done a lot of division so far in this class? I think so, yeah. Solving equations using addition and subtraction. So you're adding and subtracting from both sides. You're multiplying both sides. The key here is both what? Both sides. Both sides. What you do to one side, you have to do to the other side. What's that commonly referred to as? The golden rule of algebra. Good job. Solving multi-step equations, that's essentially just sometimes you're going to have to add things to both sides and maybe divide both sides. You've done that a lot? We sure did. And then linear equations and problem solving. What's that linked to? This right here is also linked to word problems. Word problems, exactly. Coordinates and scatter plots. Hey, you asked about that, Ashley. How confident are you making scatter plots? What's a really important thing to do when you're making your scatter plots? What's one important thing to do? What's one important thing to do when you're making a scatter plot? Yes, that's a necessary stop, but what's also really important? Really? Being exact. If you're trying to draw some conclusion, which is sometimes what you're going to do, if you're not clean and neat, what happens to your conclusions?
It's not clean and neat.
Yeah, exactly. You get a bad conclusion. So be careful. Label your axes. Label your points. You know what I mean? So if it's just like a bunch of points on the paper but nothing else, does that communicate to me, the reader, what you're thinking? No. Graphing linear equations. Graphing lines. We know a bunch of ways to do that. Point slope, slope intercept, taking 2 points, connecting them. How many points do you need to define a line? 2. Once you have 2, what can you do? Connect them. What are the 2 easiest points generally defined on a line? And yeah, find the x and the y-intercept, connect them, and you're done, right? Is that always the easiest way? No, sometimes there's easier ways. Sometimes. The slope of a line. What is slope? Remember how I asked you this like 5 times in a row on 5 consecutive quizzes? Can anybody define slope for me?
Okay.
It's the increase in going up and down, vertical increase for every horizontal increase to the right. So it's the ratio of vertical change to horizontal change reading from left to right. For every unit you go unit you go over 1, how far up do you go? So what happens if you go down? What does that mean about the slope? Negative. Down from left to right is negative, up from left to right is positive. Quick graphs using slope-intercept form. What was slope-intercept form? Y equals plus b, right. Functions and relations, domain and range of a function in notation. The domain, does anybody remember what the domain of a function is? It's the set of, anybody remember? Inputs. So everything that goes in is the domain. What's the range? Outputs, right. Remember those like blobs of numbers I would have? 6, 8, 10, right? Now it's something like this. I'm just making up a function. What's the domain? 1, 2, 3. What's the range? Simple as that. Okay, here's some important stuff. Write linear equations in slope-intercept form. That was y equals mx plus b. Write linear equations given a point and a slope. Y minus equals. That's important. Write linear equation given 2 points. That's almost the same as 5.2, except they're not giving you the slope, so what do you have to find? And then once you have the slope, you have a slope and 2 points. Is that more information than you need? Yeah. Them giving you 2 points is the same thing as giving you the slope. Good. Fitting a line to data. What is that? What do you do first if you're fitting a line to data? What are you going to start with? A lot of data. And what are you going to do with the data? Graph it on as a scatter plot. And then you're going to use a ruler and make your line of best fit and then come up with an equation. We did that a bunch of times. Another thing that's really important here is we did it a second way too. In addition, kids, in addition to doing it by hand, what did we also do? With a calculator. Part of the test will be calculator, part of the test will be non-calculator. So there are only a few things that we did with a calculator. Make sure you know how to do them. This is a really key one to remember how to do. And then predicting with linear models. If your data set is like this, and you came up with an equation, what can you do with this area? You can make predictions on that area. Yes. Moving on here. So the calculator. Make sure you remember how to use your calculator. Kind of important. Kind of important right there. Multiplication property of exponents. Do we just do that? Oh yeah. 0 and negative exponents, division, scientific notation, adding and subtracting polynomials, percents, and Pythagorean theorem. Do we just do this? Is this pretty fresh in your memory? Just did this. Or it should be, right? You also, just did this. I was thinking this and writing did at the same time. It's amazing what happens when you're having fun. Okay. So overall, you should have a pretty good grasp of what's going on. What I would like you to do now, Ashley, what do you think the answer is?
We're supposed to find the answer for x and y both.
Correct. That's, yep.
X equals 4 and y equals 1.
Correct. How would you check that answer? Plug it in and see if it makes it true. 2 times 4 plus 1, what does that equal? 9. So that's happy. And what does y equal? 1 equals, does 1 equal 3 times 4 minus 11? Is that true? 1 does equal 1. So yeah, you are happy. So does it check? Yes, it's really important to check. You can check it pretty quickly. Okay. Is that a nice answer? It's not bad. Could you theoretically graph that and find the intersection point? This isn't in slope-intercept form. You'd have to put it in slope-intercept form to graph it. It might help you. What would you do to both sides of that top equation to put it in slope-intercept form? Subtract what? Yeah, subtract 2x. Y equals negative 2x plus 9. So one's going down, one's going up. They intersect. It's kind of nice. Okay. And when you graphed these data, the data looked like this, right? It kind of looked like it was going up like that. And when you drew your line of best fit, what did it look like? So what do you notice? It's now right here. It's below, right? So in this case, so I'm saying if you did all the work correctly, you would get an answer like this if you use linear regression. Absolutely. Absolutely. So this right here, what does this say? Does this function, is it best modeled by a line? No. So later in other math classes will you learn how to use other functions? Sure. But did you do all the work correctly if you got something like 48,500? Yes. You did all the work correctly. You made your prediction based on a linear model. Absolutely. This data set wasn't super linear.